Delta 1943, cancel takeoff clearance.
Imagine flying a plane with the help of an AI co-pilot that can understand your attention, cooperate with you, and adapt to any situation. Sounds like science fiction, right? Well, not anymore. We're going to know how it works, so stay tuned and find out. Airline close calls are incidents where two or more aircraft come dangerously close to each other, either in the air or on the ground, and risk a collision. These incidents can be caused by human error, such as mistakes made by pilots or air traffic controllers, or by technical issues, such as faulty equipment or bad weather. Airline close calls can have serious consequences such as injuries, fatalities, or damage to the aircraft. A Southwest Airlines flight had to cancel its landing at New Orleans Airport on July 2, 2023, when a Delta Airlines 737 was about to take off from the same runway. The quick action prevented a potential crash by a few seconds. A similar incident happened when an American Airlines jet was speeding down the runway and barely avoided a Frontier Airlines plane that had crossed its way. Soon after, a German airliner also had a close call with the same Frontier plane. The Federal Aviation Administration, in records obtained by the New York Times, said the planes were so close that they touched each other's skin. These are some examples of the alarming incidents that have been happening more often than previously known in the US aviation system. According to a New York Times investigation, there have been multiple close calls involving commercial airlines per week this year, based on internal FFA records and confidential safety reports filed by pilots and controllers. In July alone, there were at least 46 near-miss incidents involving commercial airlines. These incidents pose a serious threat to the safety of passengers, crew, and aircraft, as well as the reputation of the US aviation system, which is considered to be the safest in the world. The US commercial airlines have not had any fatal crashes since 2009, but one close call is one too many. The FAA and the aviation community are pursuing a goal of zero serious close calls, a commitment from the Safety Summit in March. The investigation also revealed that the US aviation system is facing several challenges that contribute to the frequency and severity of close calls. One of them is a lack of warning systems at most US airports to help prevent collisions on runways. Another one is a chronic understaffing of air traffic control facilities, which leads to increased workload and stress for controllers. A government audit released in June found that 77% of critical air traffic control facilities in the US are staffed below the recommended threshold. The investigation also found that the FAA and the aviation industry have not taken enough action to address these problems and improve safety. The FAA has taken some steps to advance its goal of zero serious close calls, such as investing $100 million to reduce runway incursions at 12 airports, but more needs to be done. The FAA also issued an industry-wide call to action in March, urging airlines to reinforce adherence to published processes and Producers 6. The close calls are a wake-up call for the US aviation system, which needs to improve its safety culture and practices, especially as travel demand rebounds from the pandemic and runways become busier. The FAA and the aviation industry need to work together to implement effective solutions and prevent potential accidents or errors. The safety of millions of travelers depends on it. AI Copilot can monitor the situation, provide guidance, and intervene when necessary to ensure safety and efficiency. AI Copilot can also communicate with the human pilot of and understand their intention and intentions. One example of an AI copilot is the Air Guardian system developed by researchers at MIT CSAIL 123. Air Guardian is a system that uses eye tracking technology to track where the human pilot is looking and saliency maps to show where the computer system is focusing. Saliency maps are visual representations of the importance or relevance of different programs in an image. They help the computer system understand what the human pilot is paying attention to and vice versa. Air guards can detect when the human pilot is distracted or misses something important and intervene accordingly. For example, suppose a human pilot is looking at the wrong monitor or fails to notice an obstacle or a warning signal. In that case, the computer system can alert the pilot to take over the control temporarily. This way, Air Guardian can enhance the precision and safety of the flight and prevent potential accidents or errors. Air Guardian is based on two key technologies, a cooperative layer and a liquid neural network. The cooperative layer is an optimization-based method that balances the control between the human and the AI based on their intention and rewards. This optimization-based cooperative layer uses visual attention from humans and machines and a liquid closed-form continuous time neural network, CFC, that can model causal relationships. The system can be trained end-to-end using raw images as input and can adapt to different situations and demands. The system is not rigid or fixed, but rather flexible and dynamic, ensuring a balanced partnership between humans and machines. Air Guardian has broader implications beyond aviation. It can be applied to other domains where human-machine cooperation is essential, such as cars, drones, and robotics. The system represents a new paradigm of human-centric AI-enabled systems that can augment human capabilities and performance. Air Guardian has been tested on different aircraft platforms and has shown promising results in reducing the risk levels of flights and increasing the success rate of navigating to target points. Another example of an AI copilot is the ALIAS system developed by DARPA. ALIAS stands for Aircrew Labor and Cockpit Automation System. ALIAS is a system that can learn from existing pilots and aircraft systems and provide automated assistance to reduce workload and improve safety. ALIAS can also interact with human pilot using speech recognition and synthesis. ALIAS can perform various tasks such as flight planning, navigation, monitoring emergency procedures, landing and takeoff. ALIAS can also adapt to different aircraft types and scenarios. ALIAS is designed to be portable and removable so that it can be installed or uninstalled easily. ALIAS stands for Aircrew Labor and Cockpit Automation System. It is a program developed by DARPA, the Defense Advanced Research Projects Agency of the United States. The goal of ALIAS is to create a flexible, extensible automation architecture for existing crewed aircraft that enables safe, reduced crew operations, which facilitates the addition of high levels of automation into existing aircraft. It also provides a platform for integrating additional automation for autonomy capabilities tailored for specific missions. ALIAS consists of a drop-in removable kit that can be installed in the cabin of an aircraft where it can take control and fly missions from takeoff to landing, as well as handle emergencies based on existing vehicle information, procedures, and flight mechanics. The kit fits under the cabin floor and connects to the existing mechanical, electrical, and diagnostic system of the aircraft. Once installed, pilots can communicate with ALIAS using gestures on a tablet computer or voice commands. ALIAS uses a combination of software and hardware technologies to achieve its objectives. Some of the key technologies which are Sikorsky Matrix TM, suite of autonomy technologies developed by Sikorsky, a Lockheed Martin company that forms the core of ALIAS. Matrix TM enables ALIAS to perform complex tasks such as flight planning, navigation, monitoring, emergency procedures, landing and takeoff. Matrix TM also allows ALIAS to adapt to different aircraft types and scenarios by using machine learning and data-driven methods. ALIAS can reduce human errors and fatigue by providing assistance and backup in critical situations. ALIAS can optimize flight efficiency and effectiveness by using advanced algorithms and sensors. ALIAS can also enable crew capabilities such as collaborative autonomy, where multiple aircraft can coordinate their actions autonomously. What do you think of this system? Do you think it can improve human-machine collaboration in other domains as well? Let us know in the comments below. Please give it a thumbs up and share with your friends and subscribe to this channel for more videos on AI and aviation.